بسم الله الرحمن الرحيم. أعزائي طلبة شهادة الثانوية العامة قسم رياضيات، النهاردة إن شاء الله هنبدأ أول درس في الهندسة الفراغية. طبعا الهندسة الفراغية دي تعتبر الوحدة الثالثة من الجبر. امتحان الجبر مع امتحان الهندسة الفراغية. هندرس أول حاجة في الهندسة الفراغية اسمها إيه؟ المتجهات في الفراغ 3 dimensions أو 3 أبعاد. Welcome my dear student in our math program for secondary 3. Today we are taking new lesson in solid geometry. It's titled Vector in Space. Solid geometry. Vector in space. Dear student, the first we studied position vector in space. What you meaning of the position vector of point A? In this case, we have point A with 3 dimensions: AX, AY, AZ, with respect to the origin point. What is the origin point? In space O 0, 0, 0, AX 0, AY 0, AZ 0. The position vector is defined as the directed line segment whose starting point is point O and end point is point A. Look at vector A has 3 components: AX, AY, AZ. AX is called component of vector A in direction of x-axis. AY is called component of vector A in direction of y-axis. Also, AZ is called component of vector A in direction of z-axis. What is the norm of the vector? If we have vector A has 3 components: AX, AY, AZ, then the norm of vector A square root AX square plus AY square plus AZ square. What is the norm? Length of the directed line segment which represent the vector. Remember, dear student, length of directed line segment which represents the vector is called norm. Example. Dear student, if we have vector A 2, -3, 1, vector B 0, 4, -3, then the component of vector A in the direction x-axis is 2. Also, component of vector B in direction of z-axis is -3. If we have vector norm of vector A, we find square root component of AX square plus AY square plus AZ square. Therefore, vector A, its norm square root 2 square plus 1 square plus 3 square. Answer is square root 14. What is the norm of vector B? By the same method, we find bx square plus by square plus bz square under square root. Therefore, norm B is equals 5. Why? because 4 squared 16, negative 3 power 2, 9, 16 plus 9 equal 25. What is the square root of 25 is 5. The vector B lies in the YZ plane. Then component of vector A vanishes in the direction of x-axis. Now we are translate new title is called adding vector in space. If we have two vectors, the first vector A equals three components AX, AY, AZ, and vector B BX, BY, BZ. Then we have C vector equal sum of the two previous vector A vector plus V vector. When we add A vector plus B vector, we add component of A and B in X, and Y, and Z. Then A vector plus B vector equals new vector is component AX plus BX, AY plus BY, EZ plus BZ. This vector is called C vector. C vector equals CX, CY, CZ. Example. Dear student, if we have vector A negative 2, 3, 1, vector B 0, negative 2, 4, then when we add A vector plus B vector, we add AX with BX, AY plus BY plus BZ plus AZ. Look at the first vector negative 2, 3, 1. Second vector 0, negative 2, 4. We add the first component from A with the first component of V. Negative 2 plus 0 equals negative 2. Second component in A plus second component in B, 3 plus negative 2 equals 1. Third component in A plus third component in B, 1 plus 4 equals 5. Then A vector plus B vector equals negative 2, 1, and 5. Now we are translate to properties of adding vectors in space. What is the properties of adding vectors in space? Dear student, what is the properties of the two vectors, the last in the secondary or last year we were studied addition of the two vectors in two dimensions. The first is closure property, commutative property, associative property, and product of real number by any vector. But in this case, we are studied properties of vector in space or in 3 dimensions. Look at the properties of sum or adding two vectors in space. Number 1, closure property. What do you mean of the closure property? If we had A vector, B vector belongs to R3 or 3 dimensions, A and B belongs to R3, this is closure. The second is commutative property. What is the commutative? What do you mean of the commutative property? If we add A plus B vector, A vector plus B vector equals B vector plus A vector. Remember, what you mean closure? If you have two vectors belongs to R3, then each of A and B belongs to R3. If we have two vectors belongs to R3, then its sum or its adding must be belongs to R3. What is the property? It's called closure. But commutative property, what you mean commutative? First plus second vector equals second vector plus first vector. A vector plus B vector equals B vector plus A vector. Number 3, associative property. What do you mean of associative property, dear student? If we have 3 vectors belongs to R star as A, B, and C, if we add A plus B, then add the result with C equals, when we add B plus C vectors, then we add the result with A vector. Number 4, zero vector. What you mean of zero vector or 0, 0, 0 is called identity element. Identity element in addition is called zero vector. A vector plus zero vector equals zero vector plus A vector is equals A vector. The additive inverse. What do you mean of the additive inverse for every vector? We have A vector, AX, AY, AZ. What is the additive inverse of A vector? X and student. This vector belongs to R star. Then there are additive inverse of vector A is called negative A vector equals negative AX, negative AY, negative AZ. Remember, dear student, if we add any vector with its addition inverse, the result is, yes, X and student, zero vector. When we add AX plus negative AX, AY plus negative AY, AZ plus negative AZ, answer is 0, 0, 0. What is the vector? Is called, yes, additive identity vector or zero vector. Dear student, if we have a vector plus its inverse is equals negative A plus A or commutative, answer is zero vector. We know that commutative property means A vector plus negative A vector equals negative A vector plus A vector. Now we are translate to multiplying vector by scalar number. If you have a vector AX, AY, AZ belongs to R3 or space and K belongs to R. What is R? Real numbers. Then when we multiply K by A vector, we multiply K by each component of AX, AY, AZ equals KAX, KAY, KAZ. This vector must belongs to R3. Now we are translate to important example. Look at, dear student, when we multiply 3 times vector, each component to negative 1, 4. We multiply 3 times 2, 3 times negative 1, 3 times 4. Answer is 6, negative 3, 12. when we multiply negative 2 by vector 1, negative 3, negative 4, answer is negative 2, 6, 8. Now we are translated to properties of multiplying vector by a real number. If we have two vectors, A and B vector belongs to R3, KL, or K and L belongs to R or real numbers. Then we have distributive property. What is the meaning of distributive property? When multiply real number K multiply by adding two vector, we distribute K multiply A plus K multiply B. Dear student, if we have two vectors and we add these two vectors, after that multiply K by adding two vectors, we distribute K multiply A vector plus K multiply B vector. Look at the student. When we multiply, bracket contains K plus L times A vector. Remember, K and L belongs to real number, but A vector belongs to X and student R3. What you mean R3? Yes, 3 dimensions, has 3 components, AX, AY, Z. Then we distribute K multiply A plus L multiply A. Now we are translate to associative property. What do you mean associative property? K times L times A vector equals what? L times K A vector equals what? KL multiply A vector. If we have vector A and we have two real numbers, we find K times L times A vector or L times K times A vector, or multiply by two real numbers. After that, multiply the vector A. Example. If we have A vector negative 1, 5, 2, B vector 4, negative 1, 3, find 2A vector minus 3B vector. Remember, dear student, 2, negative 3 belongs to R. A vector, B vector belongs to R3. Look at 2A vector minus 3B vector. We multiply 2, multiply vector A, minus 3, multiply vector B. Answer is negative 2, 10, 4, minus 12, negative 3, 9. Look at negative 2, negative 12, negative 40, 10, minus 3, 10 plus 3 equals 13, 4 minus 9, negative 5. Then 2A vector minus 3B vector, answer is vector, each component negative 14, 13, and negative 5. Look at another example. Find the vector C where 2C vector plus 3A vector equals 2B vector. Look at the solution. Since 2C vector plus 3A vector equals 2B vector. Look at, dear student, this example. The required is C vector. We have equation. Left hand side contains 2C vector plus 3A vector. Right hand side contains 2B vector. The required is find C vector. In this example, we find 2C vector by add negative 3 vector, 3a vector in both sides. Look at 2c vector equals 2b vector minus 3a vector. By adding negative 3 or addition inverse in both sides, negative 3a in left hand side and right hand side, then 2c vector equals 2b vector minus 3a vector. We find 2b vector by multiply 2 times vector b. After that, 3a vector, we multiply 3 by vector a. After that, we subtract 2b minus 3a. After that, divided by 2 or multiply by half. Then 2c vector equals 2 times b vector for negative 1, 3 minus 3 multiply negative 1, 5, 2. Then 2c vector equals 8, negative 2, 6 plus vector 3, negative 15, negative 6. Answer is 11, negative 17, 0. Look at, dear student, this vector is 2c vector. Multiply by 1 over 2 or divided by 2 to find the value of c is half multiply 11 minus 17, 0. Answer is 11 over 2, negative 17 over 2, and 0. This is vector C. Equality of vectors in the space. Dear student, now we are translate when two vectors are equals. If we have two vectors A and B, we have the first vector A has three components, AX, AY, AZ. B vector equals BX, BY, BZ. A vector equal B vector when the component of X in each one, component of Y in each one, component of Z are or must be equal. Therefore, A vector equal B vector if and only if AX equal BX, AY equal BY, AZ equals BZ. Example. Find the value of L, M, and N which make the two vectors A vector L minus 4, M square minus 3, 1, B vector 5, 1, N square equal. Dear student, this example is very important. Find the value of L, M, and N if two vectors are equal. We have two vectors, A and B. A vector equal B vector must be AX equal BX, AY equal BY, AZ equal BZ. We have three equations. From three equations, we solve it to find the value of L, M, and N. Dear student, look at the solution. The solution is, since A vector equal B vector, AX equal BX, then L minus 4 equals 5. What is L? L equals 9. AY equal BY, then we find AY, component of AY is M square minus 3. Component of BY is 1. Then M square equals what? X and student 4. What is the value of M? X and student positive or negative 2. m square equal 4, m equal positive or negative 2. After that, az equal bz. We have equation. What is the component of az? N square. What is the component of bz? 1. Then n square equals 1. What is the value of n? Also equals positive or negative 1. Then we find the value of L, the value of M, and the value of N when two vectors are equal. The unit vector. Dear student, what do you mean of the unit vector? Is a vector whose norm equals the unit length. What is the unit length? Is 1. Example. A vectors negative 3 over 13, 4 over 13, 12 over 13 is a unit vector. Why? Because when we find norm A by using square root, ax square plus ay square plus az square. Look at negative 3 over 13 square plus 4 over 13 square plus 12 over 13 square. Answer is 1. What do you mean? A is a unit vector. What do you mean unit vector? It is a vector which its norm equals 1. What is the norm? A vector. Norm A vector means square root ax square plus ay square plus az square. Fundamental unit vector. Now we are translate to fundamental unit vector. We can represent the vector by using fundamental unit vector. What do you mean of fundamental unit vector? I, j, k. I n o x, j on y, k on oz. Look at, dear student, 3 dimensions, ox, oy, oz. I vector represent ox, j vector oy, k vector oz. Then I vector is the unit vector. Unit vector in x, then the component of x is 1, but 2 components in y and in z is 0 and 0. When we find norm I, answer is 1. This unit vector in direction ox, but j unit vector in direction in oy. Also k vector equal k unit vector is 0 0 1 is norm, it's norm 1 unit vector on direction oz. Fundamental, it is a directed segment whose starting point is origin point and its norm is unit length. أعزائي طلبة شهادة الثانوية العامة، في نهاية الدرس عرفنا إن في فيكتورز أو متجهات في الفراغ. المتجهات ديت زي ما كان درسنا المتجهات في تانية ثانوي على بعدين، بندرسها في 3 أبعاد وبنعرف ما هي المعطيات اللي أنا بديها في المتجهات في 3 أبعاد، والصفات أو العمليات اللي هي الجمع والطرح والملتبلاي. أتمنى أن نكون وفقنا في هذا الدرس، والسلام عليكم ورحمة الله وبركاته.